So we are discussing a filter and oscillator topic. Today is a Buddha Purnima. So may Lord Buddha guide us on the path of love, peace and truth. Happy Buddha Purnima to you and your family. Hope all of you have heard Buddha name. Let me go to the next vein bridge oscillator. But before we continue the vein bridge oscillator, let me ask you a few questions, and I want each one of you to type your answer in the chat box, whether it is right or wrong. And all these things are already discussed in the either online class or offline class. Just do the revision, then we can continue the discussion. Type your answers in the chat box. Let me see how many of you will type within a short time. I'll be happy to see your name, and I'm sure I'll not be able to read all the names because you people are going to type your answers so fast. Gain of the inverting amplifier, what is the equation for that? Just revise so that everybody will recall that. Gain of the inverting amplifier is given by 1 plus RF by R1. Vinay Kumar has typed, and Anusha, Vinayak, Sita, Rakshita, Shreya, Nishant, and Abhinandan, Pooja, Naina, all have typed. Namita, Rakshita, Ulvesh, Kirti, Diksha, Manjunath, Omkar, Shreya, Akshay, Vishal, Umakant, all have typed the answer. Siddharth, Sneha, very good. And Sumati, Ibrahim, Sumati has attended today, very good to see her. And let us go to the next question. Muthu, Nishchal, and Divya, Parvati, everybody has answered. Rakshita, Karnam has answered that. So let us go to the next. What is the question? Gain of the inverting amplifier. Is it inverting or non-inverting? What all of you have typed. Then I will ask the second question. Gain of the non-inverting amplifier. Then let me see what you type. Type it now. What is the gain of the non-inverting? Anybody can type both together. Inverting amplifier and non-inverting amplifier I am asking. And you can type both. Beginning you told all of you inverting amplifier 1 plus RF by R1. Now I am asking non-inverting amplifier. What is the gain? Fast. Okay, Anusha is telling, sir, 1 plus RF by R1 was non-inverting. Very good, Ulvesh. What was the question earlier we asked? Again of the inverting amplifier. See, now everybody is typing. Minus RF by R1 for inverting, sir. 1 plus RF by R1 is for non-inverting. But you can see the chat box. Even it's recorded now. Most of the students, when somebody told some answer, blindly they follow it, which is most dangerous. You think, write your own answer whether it's right or wrong. You can discuss later. First, jo bhi aapke man mein hai, just type it. Most of the students, they followed because somebody typed wrong. Bah, you might have heard, no? One kuri hanatandre saal ka hokko ella antaralla hangagbardu. I think Namita is typing again. Inverting is 1 plus RF by R1, sir. Somebody is typing non-inverting is 1 plus RF by R1. See, we have already spent a lot of time for that, and already we have done the derivation also. I told you people to revise. I never expected these different answers from you people. So, I'm sure you people will do the revision. And inverting is a minus RF by R1, Namita, and non-inverting is a 1 plus RF by R1. So please remember these equations and don't blindly copy. It has happened, even though it was an open book test. I think last time or before that last time, somebody has written wrong, and everybody has sent same information to others. Everybody has written wrong because one person has written wrong. So because of this open book test, they copied from others. We say copy from the book. Why you people want to copy from others? It's a dangerous. Let me go to the next. What do you mean by loading effect? Somebody can type in the chat box something, whatever you understood. The 1, 2, 3 words, not a explanation in depth. What do you mean by loading effect? One line you can type, and let me ask another question. A designer, okay, Vinayak Damodar is effect source due to load resistor. Okay, something else, very good. Vinayak, something you have written on, something is always better than nothing. Let me wait for others to type. High input impedance, is it a loading effect, or loading effect will not be there if high input impedance is there? Shri Harsha. Effect on the source by load impedance. Okay, Anusha has typed. Very good. Anybody else want to say something? Loading effect का मतलब क्या होता है? When I cascading 2 stages, what do you mean by loading? This has been already discussed, and video is also uploaded in the YouTube long back. And also I told many times to see it. The current is drawn from the previous circuit. Shreya Umarani, I'm very happy with you. I'm observing most of the classes. You are giving a very good answers. I'll be happy to talk to you anytime. Totashri has given, if next stage draws a current from the previous state. Yeah, Totashri is correct. Pawan Kumar, impacts of the electrical properties, voltage, current, resistance of a circuit due to what? Load, you have to add Pavan. Manjunatha, low effective impedance, effect on source by load impedance. Rakshita, okay, very good. Many answers are there. Now, can you design a circuit for a gain equal to 1? And can you design a circuit for a gain equal to 11? Effect of the source by a load impedance, Preeti is telling. Very good. Effect of source by load, I think same answer. Low effective impedance connected to the, okay, because you have their effective impedance. Yeah, different sentences they are telling, but remember, if next stage draw more current from the previous stage, I can say it is a loading problem. And now anybody can give a suggestion how to design a gain equal to 1 or gain equal to 11. If you tell, I'll be happy. Just think on that. A question is asked in the lab exam, maybe theory exam, main exam, or maybe IA. They are asking you to design for particular, maybe 0.3, 0.7, 1.2, 11, something like that, or maybe -1, -11. How to design? This was given as a homework to you people, and I'm sure at least 1 or 2 students will type how to do it. And design of a circuit of a gain equal to 11, gain equal to 1, and design a circuit or amplify a particular frequency. Say 10 kilohertz I am using. Shreya Umrani is telling, sir, 11 is take a non-inverting and take a RF equal to 10 ohm, R1 equal to 1 ohm. Thank you, Shreya. You be here after the class. I will talk to you. Anusha is telling, same. I think Rohit Shet is telling, I use an inverting amplifier for, I didn't understand which, whether he's telling for gain equal to 1 or gain equal to, RF equal to R1 means he's talking about 1. Okay, Rohit Shet, correct, but I don't want any phase shift if that sentence is added. What changes you are going to make to your circuit? I design a circuit to amplify, say, particular frequency, 6 kilohertz, 10 kilohertz, something I'll give her. Rakshita, she's telling RF equal to 1K, R1 equal to 1K. Gain is 1, inverting circuit I don't want, phase shift equal to 0 I want. So some suggestions you have to make, what changes you have to make, think on that. And what do you mean by transducer? Hope all of you have studied a transducer. By taking R1 ohm, R1, then gain of a non-inverting amplifier, gain is 11. Okay, 11 is correct, Totashri, and Preeti Jadhav is also, gain is 11, non-inverting, correct, and Rajat is okay, and but non-inverting is correct, Rajat, but inverting you have to think. And Ashish Kulkarni is telling R1 equal to RF, but if I don't want any phase shift, it's not a -1, or you can say 1 with a phase shift equal to 0. What is your idea next that you have to think? Transducer. Hope all of you know the transducer, what the transducer does. Transducer, we have used already in the circuit. All of you know the meaning of a transducer, what it does, which converts one form of energy into another. Ulvesh, very good. Omkar, Rakshit Karnan. Most of the students, they are giving correct answer. Convert energy from one form to another. Diksha Datnal, she is telling, very good Diksha. Abhinandan Appannavar is telling Omkar. Everybody is telling the same answer. Pavan Kamar. Pooja Patil, Anusha, Ibrahim, Rakshita Kulkarni, all are telling the same answer. And again, coming to the next, Omkar, Amok, Pavan is giving the answer. And bridges you have studied. If let me know whether you have studied or not. I am asking this question. Do you know about bridges? And if you have studied, you can say yes. When you have studied, you can type. Converts one form of energy into another. Correct. Akshay and Nishchal Shetty, Sita. All these answers are correct. Now, can you tell about have you studied bridges? You can write when bridge you have studied. Okay, Namita. When you have studied, Namita converts one form of energy into another. Divya, Shreya. Everybody is answering for a question. Very good. Yes, sir. Yes, sir. When you have studied in which topic or in which semester, and you can just add that. Let me know what you type. Divya, Manjuna, Rakshita. Everybody is telling when you have studied. Ulvei, Shumakant, Nishant has studied. Okay, when? Kab? Third semester. Very good. Very good. Third semester you have studied already bridges. Then just a small revision will be there now. Then it will be easy to discuss the vein bridge. Now coming to the another set of questions. Thank you, Pooja Kotubagi and Ephraim. Resistance of the voltmeter should be how much? Ideally speaking, what should be the resistance of the voltmeter? These are just a revision so that you people will become perfect, and whenever somebody asks or whenever you need, you can recall these answers. Rajat is typing infinity. Don't copy from others. Simply type what you know. Sometimes first person may write wrong. All 100 people should not write wrong. And Ashish, everybody is telling Muthu, Pavan, Naina, Vinay, Sita, Amog, Abhinandan, Diksha. Everybody is typing infinity. They are confident. Always is typing infinity. Very good. Most of the answers are correct. Nishant, Ganashri, Kirti, Shreya, Omkar, Umakant. Everybody is typing infinity. Next question, I think you people can expect. What is that? Resistor of the ammeter. Ammeter should be how much? 0. 0, yeah. It is better to type only O or 0. It will be fast. Aditi, Vinay Kumar, Shreya, Abhinandan, Anusha. Most of the students, they are typing it is 0, sir, ideally speaking. Very good. I am happy to see your answers in the chat box. And Kirti, Omkar, Pavan, Sneha, Siddhartha, Nabhapur. And Pavan, everybody is saying, sir, it should be 0. Let me ask another question to you people related to that only. Shri Harsha Harihar has given the same answer. Pavan, what is the resistance of the CRO? So, resistance of the CRO. Ideally speaking and practically it is how much approximately? Toteshri is telling it should be infinity, sir. Ideally, correct. Divya, Sita, everybody is telling. Somebody can type both. Practically it is how much in your lab. You might have observed or approximately. Infinity is correct, Naina, Hirima, Akshay, Pooja. Everybody is saying infinity. I want somebody to add something. Vinayak Wali is saying infinity, sir. But practically it is how much in your lab? Approximately, if somebody knows, you can add along with the infinity something. Diksha, Preeti, Ashish, Pooja, and Pavan, Anusha, Omkar, everybody is saying it is an infinity. Very happy to see everybody's name here. Let me go to the next. Anybody can write let me know who can write a tube-light set circuit. Here I cannot see what you are writing, but let me see who is confident to say, sir, I can write. I can ask him to unmute and I can ask him to talk. You can just type, yes sir, I know, with confidence. And everybody knows the tube light. Since childhood you might have seen the tube light set in your home. What is the connection between the tube, choke, starter? These are all fundamental basics. Don't say these are all not useful for LIC. Not LIC. As an engineer, one should know all these things. Students are telling the starter is connected between the choke and the tube. Okay. Any other answers are there? Let me wait and check. Nishchal is typing, sir, terminal 1 and terminal 2. What is the terminal 1 and terminal 2, Nishchal Shetty? And parallel to tube means, can you tell, tube is having 2 terminals or 4 terminals or 3 terminals, or how many terminals will be there? For tube, kitna terminals रहते हैं? Can you tell, Pavan or Nishchal, Rakshita? And all those 4 are connected to where? You can tell. You can type just one word. 4 terminals, Manjunath, that when it's correct, tube will be having the 4 terminals, and let me know where the connection. And 4 terminals, 2 end of the fluorescent tube. Vinay Kumar is telling something. I'm very happy with the Vinay Kumar. Very good. Think on that. Okay. Being an engineer, a minimum things you should know. Otherwise, nobody can say you are engineer in the home. Okay. Don't say I can write very big programs. Minimum things you should know technical. Studies the bridges, instrumentation amplifier also we have already discussed about the bridges in instrumentation amplifier. Some students are typing the starter is connected between the 2 filaments. Pavan Kumar, very good Pavan Kumar. Yeah, I think you might have seen. Especially a diploma holders could have given a very nice answer. And fluorescent light holders to make wiring connect. Yeah. Pavan is telling. Pavan, are you a diploma holder? Let me know. You can say yes or no. Are you a diploma holder? Pavan is Kumar. Yes. Why I asked? Because the way how you answer, by seeing your answer, I can understand the thinking process is different in your mind compared to others. So, because basically I am also a diploma holder, I can make out who is a diploma holder because their thinking will be different. They may not be a good scorer, but the thinking a little bit different will be there definitely. Thank you, Pavan. And remember, fluorescent, whatever you have taken tube will be having the 4 terminals, and choke is connected between the 2 terminals, opposite, left or right if you are taking. And remember, when the tube light is on, if you remove the starter also, this tube will glow. Why you should understand that? Anybody want to type the answer? Why? Why the tube will glow even though once if it is on, if you remove the starter. Without starter it will never glow. Remove the starter and switch on, it will never glow. Once if it is glowing, if you remove the starter, then also tube light will glow. एक बार ऑन हुआ ना, अगर आप स्टार्टर निकाल देंगे तो भी वो ऑन रहेगा. वो स्टार्टर, इसीलिए उसको स्टार्टर बोलते हैं. स्टार्टिंग चाहिए हो, बाद में निकाल सकते हैं आप. Using the same starter, you can switch on the more than one tube lights. Just when it is on, you remove it and connect to the next. How it is possible? Think on that. These are all very simple things, fundamentals. One should know. Okay, you don't say all these are out of syllabus, sir. अरे यार कितना डालेंगे syllabus में? You should have common sense. Now, how can I put common sense also in the syllabus? One should know. One should take interest. One should learn all these things. Anyway, let me go to the next. Vein bridge, somebody has told vein bridge we have already studied, sir. Then my work is very simple. I will not take much of time. The vein bridge is a type of a bridge circuit that was developed by Max Vein in 1891. Most of the people, when they invent something, they keep their name. Anybody knows? Somebody X has invented, but instead of keeping X name to that algorithm or that logic or circuit or array, whatever it may be, they have kept somebody's name. I repeat the question. They invent something, they keep their name. Have you seen in your syllabus? They have invented, but they have kept somebody's name. Have you seen like that? If you have not seen, just when you go to the higher semester, you may see somewhere. Observe that carefully. The bridge consists of 4 resistors and 2 capacitors. We can just note down the vein bridge circuit. We'll continue. I'll wait for some time. Vein bridge is used for a precision measurement of a capacitance in terms of a resistance and frequency. This we are not going to discuss in our LIC, but you might have studied it already. But remember this point. General AC bridges, how we say, the product of the magnitude of opposite arms must be equal. This also you might have studied. Z1 into Z4 should be equal to Z3 into Z2. Copy down this equation. You can take a maximum 1 minute. the product of the magnitude of opposite arms must be equal. I will wait for some time. A wein bridge oscillator is a type of electronic oscillator that generates the sine wave. And it's very simple, stable, most commonly used for audio frequency range. And we have already spent a lot of time on a frequency and audio range, and YouTube video is also there. Now I want you people to copy down wein bridge oscillator circuit. Both are same. Huh? Try to understand. Whichever you feel comfortable, you can copy down that. You have maximum 2 minutes. Anyone you can copy down. I'll wait for some time. Copy down. A series RC acts as a high pass filter and parallel RC acts like a low pass filter. These RC network does not allow high and low frequency. One particular frequency will be allowed. And at one frequency, output of circuit is maximum, which is called as a resonant frequency. Feedback circuit acts like a notch filter. Notch means a particular frequency will be allowed. Just copy down 1 or 2 points from this particular slide. I'll wait for a minute. So we have already copied. It's a 1 by 2 pi RC. The same circuit is with you. At FR, the feedback phase shift becomes 0. V0 by Vin, beta is 1 by 3. We are remembering phase shift oscillator, it was 1 by 29, and gain should be 29, we have discussed. Now if it is 1 by 3, gain should be 3. So that I had to adjust 1 plus Rf by R1 equal to 3. Copy down 1 or 2 points from this. I'll wait for you people to copy this. All these we have discussed: overdamped, underdamped, sustained oscillations. We have discussed the conditions for oscillations, frequency stability, audio range, use of oscillators, oscillator basics, phase shift oscillator, wein bridge oscillator. This is what we have discussed so far. And let me know how much you can recall. So just type the answers fast. First one, overdamped. What is that? Overdamped, underdamped, sustained oscillations. What is the condition we have discussed? You can type it in the chat box. Okay, Anusha is telling overdamped, sir, when gain is greater than 1, underdamped less than 1, loop gain equal to 1, sir, sustained. Yeah, answers are coming now. Again, loop gain is greater than 1, overdamped. Yeah, very good. Conditions for oscillation somebody can type, and somebody can type frequency stability means what? These two will wait. Very good. Most of the students, they are typing loop gain is greater than 1, sir. It is overdamped. Gain is less than 1, underdamped. Equal to 1, sustained. Correct. Then let me wait for a condition for oscillations. Most of you know that. Then somebody can type a frequency stability. Somebody can type a audio range. Somebody can type a use of oscillators, oscillator basics, and let me read that. Audio range, Rakshita has typed 20 to 20 kilohertz is the audio range. Very good. And somebody can say frequency stability means what? Somebody can write where we use oscillators. Some of the words what you are remembering, just recall. And if possible, type sustained gain equal to 1. Manjunath is typing. Good. And Sri Harsha is typed. Pooja Kalkani has typed. Audio range is 20 to 20 kilohertz. Pooja M. Patil has typed. Another 20 seconds I will wait. All of it type. Other also. And where we use oscillators, that also you can type. And the 15 seconds you have where we use oscillators. Audio range is 20 to 20 kilohertz. Divya. Correct. So hope all of you are remembering what all we have discussed so far. Happy to see your answers in the chat box. Let me go to the next. So now we are going to discuss square and triangular wave generators. Vinay Kumar has typed a variation of output frequency to the external conditions. This was the answer for a particular point. Okay. Gain is 1.586 for second order low pass filter. Rohit Sheth, thank you very much for that answer, because others can easily recall now. For Butterworth, second order low pass or a high pass filter, gain should be 1.586. And RC oscillator used in audio frequency. Preeti is typing, Rakshita is typing, gain should be 1, phase shift should be equal to 0, sir. Then only you will get oscillations. Very good. Many students, they are picking important sentences and they are sharing with the classmates, so that every student they can revise so much of information within a few seconds. That's the reason I ask you people to type in the chat box. See, Umakant is typing, oscillators are used in complex computers. Oscillators are used, so big list I have shown to you people. Any one you can type, including what you have in your mobile, including mobile, computer, anything. Most of the electronic gadgets nowadays, they are using oscillators. Diva is typing, oscillator is a clock for the microcontroller. Yes, it is a clock for the microcontroller. And applications are many applications are there. So let me go to the next. Before we go to the next, let me go out of syllabus for 2 minutes. Just read once. So nicely it is written. So Avagun is dangerous. Please avoid if you are doing any habits. Because of lockdown, one way it is good. This is the best time for you people to avoid Avagun. Anyway, you cannot go out if you are doing habits also. Now this is the best time for you people to avoid all the bad habits as much as possible. This is a time given by the God to you people to avoid all the habits. I am not doing that. That's the reason I have a right to tell you. Let us go to the next. Coming back to the syllabus, unit 4 we are discussing a square wave and a triangular wave generation. This we have to discuss now. This is a video is already available in the YouTube, and I have made this as a part 2. And now we will continue the discussion. What do you mean by astable and monostable? Can you type in the chat box? I'll wait for you people. Answers. No stable state in astable. Monostable means one stable state. Most of the students, they are typing a correct answer. Shreya Umrani has typed, Rohit, Umakant. Many are typing their answers. Now, we are going to discuss about astable now. Astable means your friends have told. It is like a square wave. Neither 0 is fixed nor 1 is fixed. It is also called as a free running circuit. Circuit and its operation with waveforms we are going to discuss now. And also we have to discuss a triangular waveform, how we get. And astable circuit oscillates between the two states. What are those two states, sir? High and low. Indefinitely it will just move. No external triggering is required for this. What it will do, output voltage will be, once it will be plus Vsat, minus Vsat, plus Vsat, minus Vsat, plus Vsat, minus Vsat. You will get a free running. So this square wave will get. This is a astable multi-operator and a circuit diagram of astable multi-operator using op-amp and its voltage response we are going to discuss in the next slide. Now you have a 1 minute. Copy down this. I'll wait for you people. This is a circuit diagram with a waveform. Take a minute or two. Copy down neatly. I'll try to zoom the circuit diagram in the beginning. Then I'll zoom the waveform. Copy down now. Copy down the waveforms neatly. Note down properly the V1, V2, V0 plus Vsat minus Vsat. Concluded today's class. If you have copied this, then I'll be here for another 5 minutes for any discussion, and we'll conclude today's class. Take care, be safe, have a good day. Thank you. I'll be here for another 5 to 6 minutes. Anybody is interested to talk to me, you can. Thank you.